Right, greetings, grade 12. I hope you are good. I hope you are well. We are starting with the first topic for the year as outlined in the 2022 grade 12 mathematics ATP, and that is the revision of quadratic sequences. Okay. Now, what we learned last year, and we'll still learn when we get to the topic of functions, is that when we talk about a function is a rule that assigns a given set of points to another given set of points, which means that the intention of a function is that if I have elements A, B, and C within the set A, and the elements D, E, and F in set B, what a function will do is that it will link this point with that point, it will link that point with that point, it will link that point with that point. Now, so that is a function, okay? It is a rule that assigns a given set of points to a particular set of points. How you remember it from grade 8 is you used to have a rule, let's say here inside, and they would tell you about input values, and of course you would find your output values using this rule, meaning this rule is the rule that ties this set to that set. So a function has to do with issues of relationship. So okay, it gives us a relationship between this set and that set. It has to do with association. How is a particular point related to another point in a particular set? I said all of that because there seems to be confusion with grade 12s. Okay, when you look at a graph, grade 12 think that a graph is a function. And this is wrong. This is fundamentally wrong. A graph is not a function. A graph is not a function, but a graph is a representation of a function. Okay. It's the same thing if you think about it. A picture is not you, but a picture is a representation of you. When people look at your picture, they say, oh, okay, this is what this person that I'm going to meet for a date looks like. If they look at perhaps your diary, they say, oh, okay, this is what this person is like. Okay, so a diary gives them a particular way that they can relate to you, and a picture gives them a particular way in which they can relate to you. So once we get the idea that a graph is not a function, but a graph is a representation of a function, we then realize that a function can be represented in many ways. Okay, a function can be represented in many ways. So representations of functions. A function can be represented as a graph. Okay, and we did not find time to do trig graphs, so we only learned about your linear functions. Okay, your linear function. This is, well, it's right, but let me write it the way they are. They teach you. You learned about a quadratic function. You learned about an exponential function. Okay, you learned about an exponential function. And of course, you learned about a hyperbola. Okay. It can be represented as a graph, okay? But also a function can be represented as a sequence. That's why you know that for an arithmetic sequence, you are having the general formula Tn equals to An plus B. And if you look at this formula, you would notice that this formula is exactly the same as that. It's just that the way we are representing the function, it is quite different. And then you dealt with quadratic last year, which is what I'm going to look at now. A quadratic function is given by Tn equals to An squared plus Bn plus C. And you notice that this was actually the same this was actually the same as your quadratic function. Is just that the way in which we are representing this function, it is different. Whereas with graphs, we want to find behavior of the function, and with sequence, we are trying to find the pattern of the function and thereby see the consistency of the function. You see what I'm saying to you? Okay, so we are representing a function in a form of a sequence. And I said all of that so that I can help you revise quadratic functions. Okay? Quadratic sequences, rather. Let's get to it now. I'm going to do just one example because we assume that you already have some grasp of this concept. So I'm not going to really dwell much on this topic. All right. Okay, a quadratic function, a quadratic sequence rather. A quadratic sequence. Well, we know that the general formula is given by Tn equals to an squared plus bn plus c. And of course, we know here that Tn tells us about the term. We know that A, and very important here, A is a constant. Oh no, A is half the second difference. Sorry about that. A is half the second difference, and that will make sense a bit later on. We know that B is given by B is actually a constant. Yes, B is actually a constant, and of course C is also a constant, and N tells us about the number of terms in a given sequence. Okay, so that is that. Now I want us to find some relationship, and from that relationship we will derive the first method in which we calculate quadratic sequences. All right, I'm going into this equation. I'll call this equation 1. Into this equation I'll substitute n equals to 1. Let's substitute n equals to 1. Well, if you substitute n equals to 1, well, the first term is equals to a1 squared plus b1 plus c. So t1 is given by a plus b plus c. Now let's see when we substitute n equals to 2. Okay, n equals to 2. This is 2 equals to a into 2 squared, b into b multiplied by 2, and then that's c. So t2 equals to 4a plus 2b plus c, because 2 squared is 4. Let's do it with n equals to 3. Well, you have t3 equals to a3 squared plus b3 plus c. T3 equals to 9a plus 3b plus c. And then we substituted with n equals to 4. Well, T4 equals to A4 squared plus B4 plus C. And then if you check this is 16A plus 4B plus C. Okay. Well, we can write this as a sequence. Yes, we can. Well, my first term is A plus B plus C. That's my first term. My second term is 4a plus 2b plus c, 4a plus 2b plus c. My third term is 9a plus 3b plus c. And my fourth term is it's 16a plus 4b plus c. And of course, you can continue and continue and continue and continue. Well, let us try to find the difference between this. Try to find the difference between this. Try to find the difference between that. And there's a couple of things that we will notice. All right, so if you want to find this, you'll say 4a. Very important here now. You'll say 4a minus a, so it's always t2 minus t1. 4a minus a, it's 3a. 2b minus b, it is b. C minus c, it is 0. Okay. 9a minus 4a, it is 5a. 3b minus 2b, it is b. C minus c, it is c. All right, 16 minus 9a, it's 7a. Okay. 4b minus 4b minus 3b, it's actually b. If you notice something here, this is a pattern by itself. And if you notice from here to here, we are going by 2. From here to here, we are increasing by 2a, whereas b is not affected. So that is actually, this is the first difference of a quadratic sequence is actually arithmetic. Okay. All right. Of course, as you learned last year, you would have to find the second difference for a quadratic sequence by subtracting the first difference, so that we get 2a and 2a. So we make two conclusions. One, the first difference of an arithmetic of a quadratic sequence is arithmetic. Second conclusion, the second, very important here, the second difference is equal to twice the coefficient of n squared. Okay, so it is equals to twice this. All right, so if you want to find what is this, of course they'll always give you a value here, and then you'll divide both sides by 2, but we will demonstrate that. All right, now let us show you the first method. What would you use to calculate this? It's actually the method I prefer. In high school, I used to learn, they used to tell me about simultaneous equations, but I generally prefer that. When we calculate the values of a, b, and c, in general, this is the part that you're going to use. This you use if you know your second term and third term and whatever, but I would not advise for you to use that. So for now, all of this we are going to exclude. We are only using that part. Let us consider this. We are given the sequence 8, 20, 38, and 62. Right. We want to find the difference here. Right, if you say 20 minus 8, you'll find out that 20 minus 8 is 12. 38 minus 20, you'll find out that it's 18. And of course, these are simple calculations. If you say 38 minus 62, you'll find out that is 24. Okay, really simple. 18 minus 12, it's 6, and if I did everything correctly, 24 minus 18 should also be 6. Okay, so you're done. Then you want to focus on this part. All right, you will say that 2a equals to 3a plus b equals to a plus b plus c equals to. Okay, so we first find, we work from the top to the bottom. We'll say 2a is equals to 6. Therefore, divide both sides by 2a equals to 3. Then we have 3a plus b. It is equals to what? To 12. Wherever we see a, we put 3 plus b equals to 12. That is 9 plus b equals to 12. B equals to 12 minus 9. Therefore, b is equals to what? B is equals to 3. Good. All right, and then you then are left with just one thing, and that is to find the value of C. You will say A plus B plus C is equals to what? Is equals to 8. All right, so A is 3, B is 3, and we are trying to find out what is the value of C. That is 6 plus C equals to 8. Therefore, this is 8 minus 6. And then if you look at it, 8 minus 6 is 2. Then you know Tn equals to an squared plus Bn plus C. Therefore, we have found the value of A to be 3, the value of B to be 3, and the value of C to be 2. This is the simplest method that I think you can use. I'm not going to go into the method of simultaneous equations. You will find it on the notes that I will send, but I am not really going to go into much explanation